In this video, I'm going to share how to synthesize the calling sound of a greenfinch. I'm going to use a sound I recorded previously as a reference sample. This sound is quite harmonically complex, so we'll need to use some frequency modulation to replicate its tone. Let's load this sample in a spectral analyzer. We'll select part of the waveform. We'll open up the spectrum window in RX. What we can see with this sound is that there's a lot of bunched up partials, and what this means is it sounds a bit more buzzy rather than purely tonal. Let's find the lowest pitch that the greenfinch calls at. We'll use a selection tool, select somewhere near the end. This is around about 2880 Hz. Let's start by opening up your synth, and we'll add a wavetable generator. We'll set the harmonic scale to 0, set the shift to 2880. Now we can press any note on the keyboard and it'll have this frequency. We can replicate this cluster of frequencies by using a very fast LFO to modulate the frequency of the synth. But first we need to know how fast this LFO should be. To do that, let's zoom in very far. And it's quite hard to tell what's going on when you're this far zoomed in, but we can roughly see a repeating pattern here. So there's a peak here, and a peak here, and here, and here. What we want to know is how much time passes between each of those peaks. Then we'll add an LFO. Let's make a selection which goes from one of the peaks to another. And that gives us a length of around about 6 milliseconds. As the LFO is set in Hertz, we can divide 1 by 0.006 to convert this period into a frequency. That gives us a value of around 170. If you try and type that in the LFO, you'll actually realize that it maxes out at 100. So there are a couple of ways you can get around this. Something you could do is draw in more points in the curve, and then it's now effectively at 200 Hz. This can get quite convoluted, so I'm going to swap the LFO for a curve. Then set the looping mode to infinite. And we now actually can use the duration value we got earlier. So that was 6 milliseconds. We'll then want to draw a shape roughly like a sine wave. If we go back to the spectrum analyzer, we can see that this clump of frequencies occupies around about 1500 Hz. So we'll halve that to 750. This value tells us how strongly the LFO should modulate the frequency of the oscillator. Then we need to set this curve to the plus-minus mode. We can then click this plus, right-click shift, and in this box here, we'll select a value that's around about 750 higher than this base frequency. That's roughly 3600. We can now replicate the bird's frequency curve. We can use a selection tool to learn how long this should be, and that's around about 1.16 seconds. We can also use a selection tool to learn how much this should increase the frequency, and that's around about 880 Hz. So we'll click the plus, right-click shift. In this lower box here, we'll set a number that's around about 880 Hz higher than this. Let's say 3800. We also need to add a volume curve, so I'll delete this default envelope, add a curve in its place. I'll type in the length we want, which is 1.16. Then I'll add a bit of a fade in and a fade out. I'll now make some adjustments to taste. I'll now add a bit of randomization. I'll assign this to control things such as the shift and the speed of the LFO. I'll soften the high end a bit using a low pass filter. I also find that slightly reducing the depth of the curve improves the sound. And there we have a sound resembling a greenfinch.